were doing probability and we did few examples, few questions. Exercise first done. We were doing the second exercise and did almost 9 questions. Did you get time to practice any question?
Yes, I saw till 12, 13.
Till 13. What about you, Aris?
Second check. So,
Did you get time to practice? No response. Okay, almost 90% of exercise is complete. I'll jump on to next subtopic. Relative frequency. Relative frequency is also known as probability. To work out the probability of a certain pin landing point up, you can do an experiment in which the drawing pin is dropped many times. If the pin lands point up on X occasions out of total number trials, the relative frequency of landing point up is X by N. There is actually no difference in calculation. We call it relative frequency or we call it probability.
so
When
can
an
you hear me?
experiment is repeated many times, I can hear you.
Oh,
Many times you can use the relative frequency as an estimate of the probability of the event occurring. Suppose the dice, so we are doing an experiment and roll it 25 times. The number of sixes obtained was noted and the result were as follows. After 25 rolls, the relative frequency of sixes. So we can count them 1, 2, 3, 4, 5. 5 sixes. So that's 5 out of total 25. So after 50 rolls, the relative frequency of sixes is 5 plus 4 by 50. Where is this 4 coming from? After 50 rolls, the relative frequency of sixes. After
6.
each set of 25.
This was 6. Mm,
1, 2, 3, 4, 5. Data set should be given. I guess he's just making an estimate. Supposed, he's making supposed values. Let's see. The calculation is continued for each 25 rolls and the results are plotted on the graph. Yeah, those were supposed values. As you included more and more results, the average number of success per roll settles down at slightly 0.21. For this dice, the relative frequency of success was just over 0.21. If the dice has fair, you would expect to get a 6 on 1 by 6 of the throws. So the relative frequency would be 1 by 6. So 0.21 and 0.16 as conducted in the experiment. The expected frequency would be equal to 1/6 of the total. So in 300 rolls, you would expect to get approximately 56s. That's 1/6 of 300. The dice in the experiment does appear to be biased. It would be heavy on one side, lighter on the other side, or won't have equal edges, and so on. 14.2a repeated rolls two dice and multiply their score. Repeatedly roll two dice and multiply their scores together, writing each writing down each time whether the product of the two numbers is odd or even. So we'll draw neat outcomes and boxes. Okay. 1, 2, 3, 4, 5, and 6. 2, 3, 4, 5, and 6. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Last is extra. So we're doing product of both of these. 1 into 1 is 1, 2, 3, 4, 5, 6. 2 1 times 2, 4, 6, 8, 10, 12. Table of 3, 3, 6, 9, 12, 15, 18. Table of 4, 4, 8, 12, 16, 20, 24. 5, 10, 15, 20, 25, 30. 6, 12, 18, 24, 30, 36. Okay. Writing down each time whether the product of the two numbers is odd or even. I can see these are even 1, 2, then 3. I think when I should go in order. And I'm like trying some extended lines so that would be easy to erase as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So there are 27 even out of 36, and remaining 6 and 3, 9 by 36 are odd. These are even, these are odd numbers. From your data, calculate an estimate of the probability of the product being odd using the relative frequency. So we are having 9 out of 36, that's 1 by 4. Just need to confirm it once. This is 14.2. Question number 1. That's 14.2. And question number 1. A and B, D, student own answer. C is 0.25. Okay, is expecting. I just wrote it for probability, and that was expected to roll the dice and then write. That was class experiment. Repeatedly roll 2 dice, and I just considered and wrote it. Okay, anyhow, we should have like done it multiple times. Using the sample space diagram work out, what would you think the probability of the product being odd is theoretically? This is theoretical. And that's 9 by this 1.25. That's correct. How similar or different are the two? We didn't do that experiment. We don't have those ties. Are you getting it? Are you understanding the theme of the question, part A and part B?
Yes, sir.
We should have done it by throwing the dice. And if we are getting it similar, okay, whatever happens when we actually do that experiment, when you throw it a large number of times, you will observe that it is actually coming closer to the theoretical values. A spinner has a red section and a blue section. Debbie spins the spinner 400 times. The table shows the relative frequency of the spinner landing on red after different number of spins. 100 spins, relative frequency given 200, given 300, given 400, given. How many of the first 100 spins landed on red? So always just multiply them. 0.11 times 100 is 11 times. How many times did it land on red in total? So 400 spins. I can just multiply these two and get it. 0.24 into 400. That's 24 into 4. 96 times. And I need to check this as well. This is question 2B part. Question 2B part, yeah. What is the best estimate of the probability of the spinner landing on red? So we can take average of these. 0.11, 0.15, 0.18, 0.24 divided by 4. This is 0.17. Hmm. Best estimate. That's not average. That is 0.24. Yeah, maybe because we are doing it more number of times. That is large enough. Best estimate. Why did he take the average when we were doing the graph? Throwing the sixes. Best average 0.24. Veronica has a biased coin. The probability of it landing on head is 0.7. It should have been 0.5, but that's biased, so 0.7. Veronica is going to toss the coin 240 times, work out an estimate for the number of times the coin will land on head. The 240 times is 0.7 is 168. Question 3, 168. Question 4 says Xavier rolls a dice 348 times. Work out an estimate for the number of times Xavier rolls an even number. Rolls a dice 348 times. So we have half even and half odds. 348 by 2 is 174. 174. Try question number 5. I'll read this with you. The test result of 80 students are recorded in the two-way table as shown. Band 1, Band 2, grade A, B, C, and so on. Total 80 students. The results are used to predict the result of the following year's students. The following year, there are 100 students. Find the probability that the randomly selected student will be in band 1 and get grade A. So in band 1, we are selecting from these and you will get grade A. So they are 18 out of 39. 5A1. 18. Why are we not selecting 39? Is choosing find the probability that the randomly selected student will be in band A and oh, my mistake. Will be in band A and getting grade A are 18 students out of total 80. Second said in band B and get grade C, band B and grade C should be 17 by 80. That's 17 by 80. Calculate an estimate of the number of students who the following year will get grade B. So grade B, how many students are getting grade B? 15 plus 14 are getting grade B in the current year. 15 plus 14, 29 are getting grade B out of 80, but 400, this will be 36.25, approximately equal to 36 students. 5B1, 5B1, 36. Are you getting it?
Yes, sir.
Try 5B2.
Then why did you add in band 1? Why did you add 15 plus 14? Because it stands for. Oh, okay.
Sorry, please say that again.
Sir, can you tell me why did you add 15 plus 14?
How did I get 14 and 15?
No, why did you add them?
Why did I add them? He says they get grade B, but band was not specified.
Oh,
These were students who were getting grade B. Band was not specified. But in B part, it says they will be in band 2 and get A grade. So these are those 10 who are in band 2 and they're getting grade 8, grade A.
okay.
So current year is 10 out of 80. So the following year will be times 100. 10 divided by 80 times 100 is 12.5, which rounds to 13.
13. Okay.
Right, third part.
Okay. So, sir, I'm getting 7.5, so I think it will be 8. Hello, sir.
Yeah, yeah.
I said it will be 7.5. So
Yeah,
answer will be
7.5.
8.
So answer will be 8 rounds to 8. This was 13 and 8. 13 and 8.
Mm. Hmm.
Sixth question. The spinner has an equal chance of landing on any digit from 0 to 9. And they are not in order. Four friends do an experiment when they spin the pointer a different number of times and record the number of zeros they get. Here are their results. So Steve is getting number of spins. In 10 spins he get two zeros, and relative frequency is outcome over total. One of the four recorded his results incorrectly. Say who you think was and explain why. Which result do you think is inaccurate? Hmm.
Sir, I think it will be. Yes, sir, or I think no. I think I don't understand this one.
Okay, where I think is if we would just notice that we are getting this is actually a small sample, but when we look at 150, a relative frequency is 0.09, that is approximately equal to 1,
Yes,
0.1, approximately 0.1. And then at 1000, this is again approximately 0.1. We're getting double the frequency at 200. It should not have doubled.
so like if we do,
Like
okay.
from point 1 to point 2, that is double. It might raise a little, but it should have stayed close to those values. One thing.
Oh yeah,
And the other, if it is between these two, it should somehow have frequency between these two as well. Let's see the wording. A large number of spins, we would expect him to get zeros on about
1/10 of
1
this
by
one.
10 of the spin. And why are they 1 by 10, 0 to 9? Yeah, that's more relevant, definitely. So 0 to 9, these are 10 digits. So when the
Yeah.
number is large, it gets closer to the experimental value gets closer to the theoretical value, and that's too high.
Yes, sir.
Okay, next concept is mutually exclusive and independent events. Two events are mutually exclusive if they cannot occur at the same time. For example, choosing a random number and it being both even and odd at the same time. So you might select any number, it cannot be even and odd at the same time. For example, if I ask you that I'm tossing this coin and it has head on it and on the other side there's tail, is there a chance that it will land on head?
Yes,
Yes. Is there a chance it will land on tail?
yes.
So there's a chance for both of them.
50,
But
50.
what will actually occur? Only one of them. There's a chance for both of them. Both can occur. So they are mutually exclusive, but one will occur. Getting the point?
Yes, sir.
So probability to get a head was 1 by 2. Probability to get a tail was 1 by 2. If you use this formula A or B, so left hand side equal right hand side, we are getting A or B, like I would say that head or tail. So if you get head is 1 by 2, tail is 1 by 2, that's 1. On the other side, probability of head is 1 by 2, probability of tail is 1 by 2, so that's 1. Mutually exclusive, we can say A or B, first or second. And there is a chance of both of them to occur, but one will occur. The events are independent. Now, what does this mean? You, no matter how many times you throw it, but always the chance for head to land will be 1 by 2. It will not change because of tail. Okay, let me give you another real life example. For example, you're prepared for cricket match and you think you will win, but on the day when the match is, it's raining. Now you've never practiced in rain. Now you might lose because you've never practiced in rain. So your probability of winning was affected by rain. The independent events are those, whatever happens, the probability will not be affected. And to check if the events are independent, this is a formula, and you have to memorize these formulas. Probability of A or B, that is mutually exclusive. Probability of A and B is actually the intersection part. If you draw the Venn diagrams, this is A and B. That is independent. So if you get the intersection part equal to probability of A multiplied by probability of B, they're independent.
Yes.
Okay, example, one ball is selected at random from the bag of bag containing 5 red ball and 2 yellow ball and 4 white ball. Find the probability of selecting a red ball or a white ball. So red are 5 out of this is 5 and 2, 7, 8, 9, and 11. Total 11. 5 plus 2 plus 4 is total 11. So we're selecting red ball, that's 5 out of 11, or a white ball. So that's 4 out of 11. That is 9 by 11 in total. A fair coin is tossed and fair dice is rolled. Find the probability of obtaining a head and a six. If I'll draw a tree diagram, head and tail, and then I'll have 6 outcomes 1, 2, 3, 4, 5, 6 each, like 1, 2, 3, 4, 5, 6. So, what is the probability of getting head is 1 by 2, and probability to get 6 is 1 by 6. So, head and 6 is 1 by 2 into 1 by 6. We keep on multiplying unless until the event is complete. So, head and 6, we get a probability 1 by 12. A coin is tossed and a dice is rolled. Write down the probability of obtaining head on the coin 1 by 2. An odd number on the dice 3 by 6. Head on the coin and odd number on the dice 1 by 2 into 1 by 2 is 1 by 4. Now I've just drawn it. I'll go back. Do you see this is head is decided? I'm doing the same question head on coin and odd on dice. After this, we have 3 options for odd 1, 3, and 5. And those were 1 by 6, 1 by 6 each. So 1 by 2 into 1 by 6, I was getting 1 by 12. And how many times? 3 times. So 1 by 12 into 3, I'm getting 1 by 4. And see, what do we get here? No matter how you approach the question, you'll get the same answer. Try question number 2 and let's just confirm answers before we move. This is 14a. 1 by 2, 1 by 2, 1 by 4. 1 by 2, 1 by 2, 1 by 4. Try question number 2. 2 parts, A and B.
So, it's
Yeah.
1 by 16. A is 1 by 16.
1 by
16.
16 and B part
22 by 144.
22 by 144. 1 by 16 and 22. This is 25. Let's check that. A
Yeah,
socks
it's
is,
Second,
25.
sorry?
25 by
I
144.
can do
25.
the A
Yeah.
part.
Okay.
I wrote 20.
RSA part.
Yes,
It says a sock is selected at random from a drawer containing 3 red, 4 black, 5 green. So the first socks is replaced and the second is selected. Find the probability of obtaining 2 red socks. So these are 3, 4, 5, 6, 7. 7 and 5 is 12. So to select the first red socks, this is 3 out of
12.
12.
Yeah,
And then we select the second socks is again 3 by 12. Total is not changing because it says the socks is replaced. It is put back.
yes.
So that's 9 by 144, which simplifies to 1 by 16.
Oh, okay.
And 2 green socks. Green were actually 5. 5 out of 12 into 5 out of 12 again.
Yes, it will be 25 over 144.
25 by 144. The letters of the word independent are written on individual cards and the cards are put into a box. The card is selected and then replaced. Total is not changing. And then a second card is selected. Find the probability of obtaining the letter P twice. Independent. So P is 1 out of how many are these?
11.
1, 2,
11.
3, 4, 5, 6, 7, and 8, 10, 11. Thank you. So 1 by 11 into 1 by 11 is
So
1,
1 over 121.
121. And letter E twice. So probability to get E independent.
3.
These are already 3. 3 by 11 into 3 by 11
And
is
9 over 121.
9 over 121. Fourth, the coins are tossed and 2 dice are thrown at the same time. 3 coins and 2 dice. Find the probability of obtaining 3 heads and a total of 12 on the dice. Oh my god. So if I get head, head, and head, that's going to be 1 by 2 into 1 by 2 into 1 by 2, that is 1 by 8 already. 3 heads is 1 by 8 already, and a total of 12 on the dice. So 12 is with 6 and 6 only. So to get a 6 is 1 by 6, another 6 is 1 by 6, that's 1 by 36. And I think we'll multiply these two. 1 divided by 8 into 1 divided by 36. I'm getting 1 by 288. Question 4. 4, 4, 1 by 288. Yes. And why I'm thinking, because the event is not complete yet. Until unless we complete the event, we're multiplying them. So the condition was head, 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 6, 6. So 1 by 2, 1 by 2, 1 by 2, 1 by 6, 1 by 6, and I'm getting 1 over 288. B part.
Yes.
3 tails and a total of 9. 3 tails is exactly same as heads, so that's 1 by 8 for now. And total of 9, let's just check that. So 1 plus 6 is not giving me anything. 9 is minimum 3 and 6. And what were we doing? And 2 dice are thrown at the same time. A total of 9. Okay. 3, 6, 4, 5, 5, 4, 6, 3. So this is 1 by 6 into 1 by 6 is 1 by 36 and 4 times. So basically 4 by 36, which is 1 by 9. 1 by 8 is already there. 1 by 8 into 1 by 9 simplified. And 8 into 9 is 72. 1 by 72. 4b 1 by 72. Fifth. When a golfer plays any hole, he will take 3, 4, 5, 6, or 7 strokes with probabilities. This is for 3, 4, 5, 6, and 7, respectively. He never takes more than 7 strokes. And where is the question? I'll just copy those here. This is 1 by 10, 1 by 5, 2 by 5, 1 by 5, and 1 by 10. And strokes were starting from 3, 3, 4, 5, 6, and 7. And the question is, find the probability of scoring 4 on each of the first 3 holes. Scoring 4. I think we need to know what golf is, how golf is played to answer this. 5 A is 1 by 125. I'll skip this. I don't know how we are scoring 3 or 4 on this. Let's try question number 6. A coin is biased so that it shows head with probability of 2 by 3. The same coin is tossed 3 times. That's head, and tail would be 1 by 3. Find the probability of obtaining 3 times 2 tails on first 2 tosses. So 2 tails on first 2 tosses, 1 by 3 into 1 by 3, and if it is tossed 3 times, that should be an head. It's 2 over 27. 6A. That is cheating. Why are we stopping there? He's throwing it 3 times. 1 by 9. A head, a tail, and a head in that order. Head, tail, head. 4 by 27. 6B. 4 by 27. 2 head and 1 tail. Head, head, and tail. 2 head and 1 tail in any order. I'm writing that again. Head, head, tail, 1 way. Head, tail, head, 2 way. Tail, head, head, 3 ways. So one of them is 2 by 3 into 2 by 3 into 1 by 3, and we have 3 such arrangements. So that's 4 by 9. 6C part is 4 by 9. Okay. Tree diagrams. We've been discussing them a little, but in detail. So, for example, I say that we have 5 red and 3 blue balls. So red and blue, the probability will be 5 by 8. This will be 3 by 8. And then again we take out another red and blue, whatever the condition will be. For now, I'm saying that the ball is replaced back, so the probability is not changing. 5 by 8, 3 by 8, 5 by 8, 3 by 8. This is how we draw tree diagram. And how do we use them is, if the examiner says what is the probability to get ball of same color. So this is one outcome, this is another outcome. And we multiply the chains 5 by 8 into 5 by 8. This is also multiplied 3 by 8 into 3 by 8. And these two different branches are added together. This is how we use tree diagram. And the examiner might question, find the probability that you get one red and one blue in that order. So one red and one blue in that order is this: first red and second blue. And if he says different colors, so we have again two choices. If he says what is the probability to get two blue, this is the only choice. So we multiply the branch, and across the branches we add them. A bag contains 5 red and 3 green. So 5 by 8, 3 by 8, 5 by 8, 3 by 8, so on. What is the probability that both ball are green? So this is green and this is green. 3 by 8 into 3 by 8 is 9 by 64. Example 2. A bag contains 5 red, 3 green. Ball is selected at random. This that same tree diagram. But this time one thing is said, ball is selected at random and not replaced. See, the total is changing. First understand the probability. I'll draw it again. Red and green. Here is there were 5 red and 3 green. So 5 out of total 8. And 3 greens out of total 8. Now again red and green. Again red and green. But not replaced. So denominator is decreasing. For sure denominator is 7 every time. I don't want to think about it again. I'm writing it once. Now see, first red was removed. There were 5 red. So we are left with 4. In the second attempt, when I'm taking out green, red was removed. So green are still 3. In the third attempt, green was removed. So red are still 5. In the last attempt, if one green was removed, it is 1 less than that. Another way of doing it is, if we just write this as 4 by 7, total of these two is always 1. So that is 4 by 7, this is 3 by 7, 5 by 7 and 2 by 7. See, 5 by 8 and 3 by 8, total is always 1. So then it says 2 green balls. We see green in the last line, 3 by 8 into 2 by 7. And this goes there. In the second attempt, in the second part, it says 1 red and 1 green. So this is 1 red and 1 green. You multiply them, and then green and red, you multiply them, and finally add these two to get the overall probability. Okay. Do try a few questions, and probably by tomorrow we'll be able to complete these. Probability from Venn diagram. Possibly one more class, 2 classes max, and then we'll move on to practicing past papers.